So today we are going to start a new topic that is known as ionic equilibrium. So what actually ionic equilibrium is? Equilibrium. We have seen what is the equilibrium that established between dissociated part. What are the dissociated part in that case? We know that is ions and undissociated part is known as ionic equilibrium. The dissociated part, that is ion, and undissociated part. So let's take an example. We have a salt AB which is aqueous, that is being dissociated into A plus aqueous and B negative aqueous, B anion aqueous. So this is known as undissociated part. And this is known as dissociated part. One is known as undissociated part and another is known as dissociated part. So this is the basic definition of ionic equilibrium. So the equilibrium established between them, the rate of forward and rate of backward, both are equal. The same case we have seen in the chemical equilibrium. Now, how do we define the substances in the case of ionic equilibrium? So we will further study classification of substances. So what are the classification of the substance? First of all, we will classify the substances into two parts. One is electrolyte. So what is the electrolyte? Electrolyte is which dissociated into component ion. Electrolyte which is dissociated into component ion. So which are the electrolyte? Like what are the types of bond between the element of the electrolyte? That is could be ionic bond, and or it could be polar coordinate bond. It should be polar coordinate bond, like in case of ionic bond NaCl is the electrolyte, or polar coordinate bond HCl like H2O. These are the electrolyte which dissociate into component ion. And the second one is non-electrolyte. So what are the non-electrolyte which does not dissociated into its component ion, which do not dissociate into component ion. So which ion does not dissociate into its component ion is like non-polar coordinate bond. Not coordinate bond, it could be non-polar covalent bond, which is not polar in nature, which dipole moment is 0, like urea, glucose, sucrose. So they are non-polar in nature. So whenever they dissolve in water, the positive charge and negative charge of the positive pole and negative pole of the water does not separate them into its constituent ion. So this is electrolyte and another is not electrolyte. You will keep on using the word electrolyte and non-electrolyte in further terms, right? Now, How do we classify the electrolytes now? Because non-electrolyte, they do not have any use in case of ionic equilibrium, or we don't study specifically them into an ionic equilibrium, because whenever we dissolve them in water, it does not dissociate into ions. It doesn't give any ions, so there's no sense to study that component or that molecular compound in case of ionic equilibrium. So what are the classification of electrolyte? Now when we studying electrolyte, first of all we will be looking at classification of electrolyte. So some base are completely dissociated, some base not. Some electrolytes are completely dissociated and some are incompletely dissociated, means some part remain in the undissociated form and some part remains in the dissociated form during the equilibrium. I'm not talking about the initial state or final state or whatever, but the final condition when equilibrium established. It could be final state, because equilibrium established after a certain long period of time. It could be any time whenever the rate of forward reaction becomes equals to the rate of backward reaction. That case is known as equilibrium. So on the basis of degree of dissociation, we know it it used to be known as alpha in case of chemical equilibrium. Now in case of ionic equilibrium we are using the degree of dissociation electrolytes are classified into two categories. So electrolytes are classified into two categories. One is known as strong electrolyte. So what is a strong electrolyte? Like electrolyte which are 100% ionized. That is alpha equals to 1. Or we can say 100% ionized. Alpha is 1, that is known as strong electrolyte. Like some acid A, B aqueous is dissociated into A plus aqueous and B minus aqueous. They not reverse reaction. Whole the compound is dissociated into its constituent ions. Like if we draw that time t equals to 0, then the reaction started. The concentration was C. And when the reaction is completed, and when the reaction is end, T end, when the reaction is end, it is completely dissociated and it is C and C. Initially it was 0. So what are the strong electrolyte? In the case of ionic equilibrium, how do we categorize the strong electrolyte? So the strong electrolyte could be acid, base and salt, right? One could be acid, one could be base, and when both the react, it could be salt. So all the strong acid are the strong electrolyte. Strong acid means they completely gives H plus and ions, an ion, whatever the anion is in the acid part, right? So H plus like strong acid. Strong acid, what are the strong acids? HClO4, H2SO4, HNO3, HCl, HBr, HIN. Remember, these 6 are only the strong electrolyte we know. Strong acid we know. Remaining all the organic acids or further acid, HClO3, HSO3, HNO2, HClO, all are weak acids. Apart from these 6 acids, all acids are weak. Now, what strong base? Strong base are also strong electrolyte. Whenever we're using the term strong, then a strong electrolyte. They whole completely, if we take 2 molar of the HClO4, it will give 2 molar H plus and 1 molar, 2 molar ClO4 minus. Now, strong base. What are the strong bases? So, hydroxide of first A. First A hydroxide. What are the hydroxide of first A? lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, and cesium hydroxide. We do not take francium because it is radioactive. Now in case of second A, all hydroxide except beryllium, right? Beryllium is not a strong base. Hydroxide of beryllium is not a strong base. So in that case, magnesium hydroxide, calcium hydroxide, strontium hydroxide, barium hydroxide. These are the strong base. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? These are the strong base. So we know the acids which have alpha 1 or 100% ionized. We know strong base, but what about the salt? You know, salt are made by acid and base. The neutralization reaction or complete reaction with acids and base, like NaCl. NaCl is a salt formed by a strong acid plus a strong base. If I talk about sodium acetate, it is formed by weak acid plus strong base. Now if we talk about the NH4Cl, strong acid plus weak base. Acid is HCl and weak base NH4OH. And ammonium acetate, ammonium chloride, it is NH4 ammonium chloride. And we talk about ammonium acetate, CH3COO NH4. It is formed of weak acid plus weak base. So remember, all types of salts are categorized into strong electrolyte. All have alpha equals to 1. Right? All have alpha equals to 1. Now let's come into the categorization of second type of electrolyte, that is known as weak electrolyte. So let's jump into second type of categorization of electrolyte on the basis of degree of dissociation, that is weak electrolyte. So what are the weak electrolyte? Electrolyte which are negligible, dissociated into their component ion in aqueous solution. Negligible dissociated. Generally, weak electrolytes are very less dissociated. Their alpha is not generally like 60%, 70%. It is the rare case. But in general, the alpha is like 1%, 2%, 0.01%, 0.02%. Very weak. Okay, so that is categorized into weak dissociated. Like alpha is very less than 1. Right? Like A, B in aqueous. It first dissociated into A plus aqueous and B minus aqueous. Now further both A minus and B minus form again AB plus. So at T equals to 0, its initial concentration was C, it was 0, 0. When the equilibrium was established, its concentration becomes C minus C alpha. It's C alpha and C alpha. Alpha is and solvents indicating the dissociation constant. So what are the examples of weak acid and weak base? Or weak electrolyte, or completely we know as weak electrolyte. So what are the weak acids? All the acids apart from those 6 acids are categorized as the weak electrolyte. Like we have numerous, very thousands of examples you can take apart from the 6 acids, which we have previously mentioned in case of strong acids, right? Like HClO3, you can take it like HClO2, HClO, H2SO3, H2SO5, HNO2, HF, H2CO3, H2S, some sort of acetic acid, all the types of carbonic acid, formic acid, phenol, benzoic acid, all remaining, etc. Right? Now, what are the examples of weak base? So remember, like hydroxide, apart from the first and second day, except beryllium, all are weak base. Now, there are limited amount of weak base if we look at the periodic table, but we look at the organic base. What are the organic base? Organic base do not have OH. So what? Ammonia and its all derivatives are considered as a weak base. Ammonia and its derivative, all the ammonia and its derivatives are considered as its weak base. So what are the ammonia derivatives? Like amine, we have amine gas, ammonia. Now if we remove one H and we put any alkyl group, C2H5NH2, these are the weak base. Like when CH3NH2, when we react with water, it forms like we write it as a CH2NH3OH, or like it will give OH minus, right? So it directly is not it gives OH minus and react with water. Like ammonia, when we react with water, NH3, when we react with water, it forms NH4OH. So this act as a base. Whenever ammonia will dissolve in water, it act as a base by reacting with water, right?